Buddy. Hi everyone. Hello guys. Am I audible and visible to everybody? Hello everybody. Yes. Hi Ishan. How are you, beta? Hello everyone. Yes. Hello, Technical India, fascinated boy Himanshu. Okay, like a lot of names are coming. A lot of people are joining right now. So yes. So guys, last time we were discussing about the properties of solid, and we had taken some questions as well. That came in the last year of JEE. Okay, so this time we are discussing about the fluid mechanics, and basically the fluid mechanics we have divided into two parts. One is fluid mechanics 1, and the second one is fluid mechanics 2. So in the mechanics 1 we'll be discussing about the pressure that is exerted by the liquid, and like apart from that we'll be discussing about this one, the surface tension, viscosity, and all these, right? And fluid mechanics part 2 we'll be discussing about the equation of continuity and the Bernoulli's theorem. Okay, so yes, so this time, yes, so I'll just give a brief idea what fluid mechanics is all about. Then we'll take a few questions on that, right? Okay. So first of all, let me just introduce what pressure is. Okay. So in the fluid mechanics, just a moment, guys. In the fluid mechanics, part one. Okay. So pressure, as you know, that pressure varies means force per unit area, right? And the pressure varies. Suppose this is a tank in which the liquid is filled up to a height of h. Okay, so at the top surface of the liquid, or you can say just above the top surface, if I ask you what would be the pressure here at point A, can anybody respond on this? What would be the pressure at point A? That would be nothing but only atmospheric pressure, right? So I'm just representing as P naught. So this is 1 atm, 1 atmospheric pressure, that is equals to uh, 10 raised to the power 5 Pascal. Okay, what about the bottom? So what happens is at the bottom, the liquid also exerts some pressure on it. So here, if I am considering this point as B, so here the pressure, total pressure would be, I'm writing it as total pressure would be P naught plus H rho G, where H is the depth, you can say this depth. Okay, or if you are taking this as a reference point, you can take it as a height as well. Okay, and here D, sorry, not D, here rho is the density, this is height, and G is the gravity. Okay, so at the bottom of any tanker or any lake, you can say if the water is filled up to a height of h, so the bottom pressure would be this much. Like I do have a bottle in my hand, where you can see that here the pressure would be different at the top surface, and at the bottom it would be different, right? So this is what we have understood here. Okay, yes, so if I give you a question here, for the good understanding of all of you, so you just tell me where the I'm going to ask you in a moment. Just a moment, guys. Okay. This one I'm drawing it with my bare hands. Just a moment. Okay. And everywhere. Okay. So everywhere the liquid is filled up to a height of h. Just a moment. Everywhere the liquid is filled up to a height of h. Okay. In all of them. So if I ask you what would be the suppose this is A, this is B, this is C, and this is D. If I ask you what would be the correct in this case, like pressure here at the bottom of A would be PA. This is, just a moment, guys. This is PA, this is PB, this is PC, and this is PD. So if I ask you where the pressure is maximum and where the pressure is minimum, can anybody respond? Yes. So Mirudang says same everywhere. So yes, guys, that is absolutely correct, because I have just told you now that pressure solely depends on the height, and rest is density, where the liquid is same in all the vessels, right? And gravity is same. We are conducting the experiment on the same place, right? So yes, so pressure would be same at every position, means here at the bottom, everywhere it is same. So I can write it in this way, that, just a moment. So PA has to be equals to PB equals to PC and PD. If I ask you what would be the where the force is maximum, what would be your answer? Force. What about the force here at the bottom? Guys, can you just respond on this? Okay, see, the force will be dependent on the area, because you know that force is nothing. I'm just taking it to the next board here. So force is nothing but pressure into area. Okay, pressure into area. So you know that pressure is same for all the vessels, right, at the bottom. But you can see that where the area is maximum, you can see that this area is pretty small. This one is a bit more, this one is large of among all of them, right? So obviously where area is large, right, the force would be less, right? So wherever the area is small, in that case the force would be more, right? So this is the logic, that's all, right? So in case C, FC, I'm writing it here, AC is maximum, right? So FC is minimum. Okay, this is a concept. This is the entire concept between the relation between the force and the pressure. It just depends on the height. That's all. So after that, we have surface tension. We have surface tension where the upper part of the liquid where the upper part of the liquid is like feeling like a stretched membrane, why? Because what happens, the molecule at the top surface will be pulled by all the molecules, adjacent molecules, and the resultant force in the downward direction, right? This is the resultant force in the downward direction. But the molecule that is inside the water, that is in the bulk space, so what happens to this molecule is it is being attracted towards all the points, right? So you can see that here the net force on this molecule would be zero. But this guy, means this molecule is experiencing some inward resultant force, and still it is able to maintain here. That's why we call this membrane, means the upper layer of the liquid will be feeling like a stretched membrane, and therefore it is having more potential energy at the surface, more potential energy. And if you wanted to take this molecule from position A to, sorry, from position B to position A, you have to do some work done. That will be stored in the form of surface energy that we calculate in this one. S into delta A, right? Sorry guys, I just forgot to write the formula for surface tension. Surface tension is represented by force per unit length, or the unit would be Newton per meter. Okay, so guys, this is like on these things we are going to do some numericals today. Okay, let's just take first numerical here. Just a moment. Yes, so there is a circular tube in the vertical plane, two liquids that do not mix each with each other, and the densities are given as d1 and d2 are filled in the tube. Each of the liquids subtend 90 degrees at the center. Means this particular liquid, the density with the d2 is subtending 90-degree angle here, and here also the one in the black also making angle of 90-degree at the center. Okay, making with some other color here, this is also 90. Okay, so the radius joining the interface, this is air liquid interface, making making this, just a moment, the radius joining their interface makes an angle alpha with the vertical. Here this is the interface, the liquid to liquids interface, right? And making some angle alpha with the vertical, this is a vertical line. Okay, so you have to calculate the ratio of d1 upon d2. This question was asked in JEE main exam 2014. Okay, yes guys, anybody? Okay, you guys just solve it from their end as well. I'll just do it here. Okay, so here what I'm going to do is, see, one point I just wanted to mention before solving it. Guys, you must have heard about the barometer, right? What is barometer? It is a device to use to measure the atmospheric pressure. What we do here is, this is a liquid, and we insert an inverted tube in the beaker, and what happens? Always remember, liquid at the same height. Means I have this beaker. Okay, so if I have 2 points A and B, this is A and this is B, so if they are inside the liquid at the same level, so the pressure here at these 2 points would be equal. Okay, that's why in the barometer, why the mercury rises, because here pressure at C and pressure at D has to be equal, and here the pressure is almost P naught, so this liquid has to rise up to balance this one, and that comes out to be H rho G, right? And P naught, and from this you can calculate the value of H, and that comes out to be 75 centimeter of mercury column. Okay, so similarly what is happening here is, what we are doing is, let me just recreate the figure on the board, just a moment. Yes, so this one is a tube I have. Oh, just a moment. Okay, so what is happening here, this is the center. Okay, and this is a vertical line. Okay, and what is happening here, the two liquids here. Okay, one is this one, just a moment. Okay, just a moment. Yeah, this one and this line. Okay, and there is one more liquid that is also making, this angle is 90. Okay, the entire angle is 90. This one is alpha, and this one is, I just need to make this figure proper, just a moment. Guys, this is also actually 90. Okay, the two these liquids are making 90 degrees at the center. Okay, so what is happening, if this is alpha, so this angle, I'm just naming it A, O, B, and this is C. So you can see that angle AOC, sorry, not AOC, This is I'm writing it as t. Okay, so angle AOT has to be 90 minus alpha, isn't it? Right. Similarly, what I am doing is, this is a vertical line, this is another line which is making, means angle between OA, sorry, OT, and angle between OB. So angle between OT and OB is alpha, right? So if I'm sketching the perpendicular on the two lines, again I'll be getting an alpha, right? So what is happening here is, if I am, just a moment, if I am sketching a perpendicular here, okay, so this one is also alpha. Let me just take to this figure actually. Yes, so what I'm doing here is, if I am just sketching this line, this is also alpha, right? And this one is 90 minus alpha, right? This is alpha, then it is also 90 minus alpha. And what I'm doing is, the main logical part here is, I have to balance the pressure, that's all. Means if I'm seeing at exactly at this vertical point here, I'm just naming it, just a moment, this point, this point I'm taking it as any point like R. Okay, here the pressure exerted by both the liquid has to be same, right? That's why it is not movable, that's why there is no net force is exerting on this. So what is happening here is, I need to calculate the pressure by this liquid, and this liquid at here, and this liquid, the one here, okay, at here. Okay, so let me calculate it here. So first of all, I'm just making the liquid portion here. Okay, here, this point, at point T, we need to calculate the pressure by this liquid column. Similarly, we need to figure out the pressure due to this entire liquid. Okay, the pressure created by the red column and pressure created by the green column. Just a moment, this liquid is till this point, the red one is till this point. Okay, so here at point T, I need to calculate. So here you can see that the pressure at point T, point P, right? Not P, sorry, P. Okay, so here you can see that on the left hand side, you can see that the pressure by red column is equals to pressure by red plus green. Okay, so guys, see this figure carefully now. So you can see that, because here the figure is not proper, let me take it here only. So what is this height, this one, what is this height, what would be this height, guys? See, if this is alpha, this is R, the radius is R, so this height would become R sine alpha, isn't it? This one, right? What about this one, this height? What about this one? This is 90 minus alpha, so this will become, if I'm writing it here as R upon this height, I'm taking it as x. Okay, so x upon R is equals to sine 90 minus alpha. Okay, I'm calculating it here, so it will become x equals to R cos alpha, right? So this height, this one will become R cos alpha, and this will become R sin alpha. Okay, this will become R sin alpha, this will become R cos alpha. What about this one, this particular height, this is small height, this one, how would you figure it out? This is, okay, I am just taking it on another board. because this is here, like the figure is pretty difficult to understand, means there are a lot of things. Just a moment, guys. Yes. Okay, so now we need to calculate this one. We need to calculate this height actually. Okay, this height, this one. So it will become this is alpha, so this is r entire, this is r. Okay, so this is r cos alpha. Okay, so this will become r minus r cos alpha, isn't it? Right, this height will become r minus r cos alpha. And now if you are taking this height, just a moment, this is also making 90, right? So this here is, you can see that this is alpha, and this will become, the remaining part is 90 minus alpha, right? So how would you figure it out? This particular angle here would be, this angle is 90, this angle is 90 minus alpha. Okay, so you can calculate here. How would you calculate? This one is r, we need to calculate this height. Just a moment, let me see it here. Yes, so this height has become r1 minus cos alpha. Okay, and this will become 90 minus alpha. So here the height, this is r. Okay, so this will become this height. Okay, because here the liquid, the pressure created by at this point will be because of this and because of this one. Okay, but here the pressure is created by, only the height is given as here. Okay, so the, this I need to calculate. Just a moment, this height, almost this one. Okay, so this height will become, this is 90 minus alpha, so cos 90 minus alpha is equals to, just a moment, this is yes, this is x upon r. So x will become r sine alpha, and this height will become r 1 minus sine alpha. Okay, so if I equate all the like, if I put it in this equation, the pressure by the red, that is h rho g. So pressure by the red would be, this height here is r1 minus sine alpha, and this height here is r sine alpha, r cos alpha, and r1 minus cos alpha. You just need to put all these things in the equation. So this is pressure at point T is equals to pressure at point T, that is r1 minus sine alpha, that is h. What is rho? Rho, you can take d or whatever. Sorry, they have given it as d1 and d2, right? Yes, so this is d1 on the left hand side is equals to r sine alpha plus r cos alpha plus, and g भी है यहाँ पे, this is d1g, this is d2g, this is d2g again, and this is r1 minus cos alpha d2g. So you can see that, guys, r you can cancel out from all of the r and g, basically from all of the terms, right? So what would you get at the end? D1 1 minus, just a moment, d1 1 minus sine alpha is equals to d2 sine alpha, d2 sine alpha plus d2 cos alpha plus d2 1 minus cos alpha, d2 1 minus cos alpha, right? Yes. So I just need to see it once more. Mm, yes, 90 minus alpha. This is d1, this is d2 sin alpha. Okay, I'm just checking it, guys, whether I have made it correct or not. So r cos alpha, yes, this is, just a moment, r 1 minus cos alpha. Okay. Hmm. Okay, and this is r 90 minus alpha. Yes. Okay. So d1 d2 sin alpha. Yes. So here d1, just a moment, d1, sorry, actually, guys, yeah, here I need to do one small thing here that I forgot to mention. Just a moment, let me just select this one, just a moment. Yeah, see here, at this point, this density I have to multiply this 1 minus cos alpha with the d1, not d2. Okay, so because this is this liquid, so that's what where we are, like, this one is okay. Let me rewrite this equation. This term would be here. Okay, so this one would be, this one would be r 1 minus cos alpha d1g. Okay, again all these terms will be cancelled out, the r and g. Okay, so what would you get in the end? d2 1 minus cos alpha. Sorry, this is not d1, this is just a moment. Yes, so this is d1 minus cos alpha, and this is equals to d2 plus sin alpha and d2 plus cos alpha. Okay, so just a moment. This figure is pretty confusing, guys. Yes. Okay, okay, okay. Again, this is pretty, this has to be on this side only. The only thing is we need to do it is, just a moment, d1 here. Okay, so d1 minus d1 sin alpha is equals to d2 sin alpha plus d2 cos alpha plus d1 minus d1 cos alpha. So d1 will get cancelled out here, and you can take this here. So this will become d1 cos alpha minus sin alpha is equals to d2 sin alpha plus cos alpha, right? So d1 by d2 will become sin alpha plus cos alpha upon cos alpha minus sin alpha, right? We just divide with the cos alpha in numerator and denominator both, so it will become sin alpha plus cos alpha upon sin alpha upon cos alpha minus sin alpha upon sin alpha. This will become tan alpha plus 1, and this is, sorry, sin alpha, right? Just a moment, cos alpha minus sin. Oh, sorry, guys, I need to divide it with the cos alpha. Just a moment. Yes, I just need to divide it with the cos alpha. Okay, 1 minus tan alpha. So this is the relation at the end you will get. Guys, I mean, this figure was pretty difficult. I mean, pretty confusing to draw here. That's why it took a bit of time. So guys, this one, A would be the correct option here. 1 plus tan alpha minus 1 minus tan alpha. Okay. And one thing I just need to tell you here, the only thing is you just need to balance the pressure. That's all. You just need to make the simple figure and just balance the pressure at both the ends. That's all. Guys, we'll just take a quick question and then we'll just wind up because we have already spent so much time. Yes, this question is here. So there is a glass tube where the two bubbles, soap bubbles are here. Okay, where the two soap bubbles are here. Internal radius is given as r. Okay, and the valve separating by the two identical ends. Initially, valve is in a tightly closed position. Okay, this was tightly closed, and a hemispherical soap bubble radius r and n2 at subhemispherical soap bubble is shown in the figure. Means here, this is the situation. I'm drawing it. This is the situation. This is just an arc, and here this is second and this is one. Here the complete hemispherical bubble is being formed. Okay, so you have to pick up the correct option here from the given options. Air from end 1 flows towards 2, no change in the volume of the soap bubbles. Air from end 1 excuse me, from towards air from end 1 flows towards end 2, volume of the soap bubble at one end decreases, no changes occurs. And the last one is air from end 2 flows towards end 1, volume of the soap bubble at end 1 increases. Can anybody respond on this? Like, what would be the answer? Yes, guys, see, I mean, I'll just take it up right away. See, uh okay, so this is the first tube, this one is the second one. Okay, so in the first case, what is happening, this is a subhemispherical is being formed. Some hemispherical means, if suppose this is a circle, let me make it here. If this is a full bubble, okay, so only this part is coming at the bottom. This is the part. This is the case 2. And if in this case, here you can see that the half hemispherical bubble is being formed here. Half hemispherical bubble is being formed means here is this much, like in this way. Just a moment. Okay, this complete half hemispherical bubble is being formed. So guys, you know that, I mean, you must have heard about you must have studied about the excess pressure in the bubble, right? So if you're considering about the soap bubble, so excess pressure is 4s upon r. So s is the surface tension, r is the radius. So if I'm just building up, you know, this the if I'm building up this like circle or the complete sphere out of this arc, so obviously my radius would be bigger, my circle would be bigger as compared to this one, right? So you can see that here the radius is more as compared to this one, right? So this r1, this is r2. So you know that r2 is greater than r1, and you know that the excess pressure is inversely proportional to the radius. So less is the radius, more is the pressure. So here the gas will flow from here to here, because here this is high pressure condition, this is low pressure condition. You can see that. That's why the air will flow from one end to the second end. Okay, this bubble will inflate, means it will increase in the size, and this will get reduced. So here the air, the option B. Okay, because it says the air from end 1 flows towards end 2. This is one end, this is two end, right? and the volume of the soap bubble at one end decreases. This will get decreased. That's what we have figured it out, right? So guys, that's all for today. Okay, and you guys can search about the Meritnation and figure a lot of things about the Meritnation from these links. Okay, thank you so much guys. I'm winding up the session now, and we will be meeting up in the next session with a new topic. Thank you so much guys. Bye bye.